So this is your first lesson on Introduction to Polygons. It's going to be a very, very simple lesson. It's just going to get to the basics, and then we're going to go ahead and move on to topics that you need to know in order to continue with this. So let's go. First thing, you want to go ahead and you can pause the video and copy down the notes if you need to. So this is the definition of a polygon. So a closed figure means that basically wherever you start, that's where you have to end, if you really want to think about like how to draw a shape. So for instance, for this triangle, we see that we can like start there at that vertex, and all that really means is that we can go ahead and if we go around, right? So if you think about, we go here and then we hit this vertex, and then we go here and we hit this vertex. In order for it to be considered closed, you would have to come back to that same vertex of where you started technically. All right, so if you want to think of it like that, right, start versus an end. So the second part of the definition talks about finite. This just means the number has to actually exist. For instance, a triangle has 3 sides. We're going to call it segments here, but 3 sides technically, right? 1, 2, and then 3. This one here has 4 sides. If you can see it, right, you actually have to be able to count them. It can't just be like an idea. You can't just say like an infinite number of sides, right? This won't work for a definition of a polygon. We get to this idea further on in math classes, but for right now, let's just leave it like that. And see, this side has how many? 1, 2, 3, 4, 6 sides. Okay, so that's what it means by closed, and that's what it means by finite. Now, the next part is going to be just a little bit harder to wrap your mind around because this is a very mathy definition. So let's see. The sides have a common endpoint, which is basically vertex. That's what you're trying to say there. Okay? So the sides have a common endpoint and they are non-collinear. All that means is that they basically they don't lie on the same line. So I'll show you an example of where this wouldn't work. So, sorry, that should say line for those of you guys that need it. Okay. So for instance, if you see here in our example of a quadrilateral, right, we have one side there, or sorry, one vertex there. So the sides have a common endpoint, right? So what that means is that we have 2 sides there, and they basically meet right there. That's the common endpoint, and the sides themselves are not on the same line. So let me just give you an example of where this doesn't work. So for instance, side, there goes our vertex, and imagine it just continues again. And then we can go ahead. So how I drew it, this is not a polygon. Even though it technically has, let's see, 1, 2, 3, 4 sides. This is not a polygon because if you notice, you have 2 sides, basically, that even though they do meet at an endpoint, i.e. a vertex, the 2 sides are still on the same line. So that's why it doesn't work. So, right, so that'll be this point here. Now the second point says that each side intersects exactly 2 other sides. So what that means is, let me go ahead and I'll show you with the last shape. So each side intersects exactly 2 sides. So let's consider this side right here on top. Okay, let's consider that one. It only intersects, or it only touches, right, 2 other sides, which are going to be that one and that one, and only at their endpoints, which is true because if you really just look at it, it'll be right there, and then it'll be right there. So that is a very mathy definition of what it means to be a polygon. If you guys get to like higher level geometry, this is actually going to be super duper important for you, and this is where you start getting more intricate stuff. So let's go ahead and looking at these here, pause the video and tell me why are these not considered polygons, and try to explain why. So go ahead. Alright, so let's go ahead and let's call this one 1, we'll call this one 2, we'll call this one 3, even though it doesn't look like it. So number 1, the reason it's not considered is because it's not closed. Alright, so if you see here, there is empty space there, and that's why it's not closed. For number 2, the reason why this doesn't work is because the sides aren't straight lines. I don't think I really hit that on the other slide, but this is actually something that's actually really, really important. It's still considered a shape, so don't confuse polygon for shape, right? It's still considered a shape, but this is not considered to be a polygon because just they're not straight lines. And then finally, number 3, it doesn't follow the rule where one side touches only 2 sides at the endpoints. So that's the rule that basically it's breaking. So for instance, let's go ahead and let's see this here. So let's imagine we're focusing on this side right here. So let's count how many sides does this side touch at its endpoints. So the endpoint is here, so it touches this side, so that's 1. Another endpoint is here, but if you notice, this one touches this one, and that one. So it touches 4 sides instead of, the 2 that we actually just need. Super random, but you gotta kind of just know it for right now. A regular polygon. So whenever you see the word regular, automatically it just means that all the sides are congruent, and then the angles are also congruent. And by angles, I technically mean like, let me change that color. So I mean like this angle is equal to that angle, which is equal to this one, right? So all of these would be considered congruent, the same. We're going to talk about how to figure out what the actual number is, but for now, just know that that's what a regular polygon is. Do you really need to know these names? I mean, maybe like you need to know those because those are the ones that I know, but really it doesn't really matter. It's just trying to show you what the names are. In fact, when we go to really like big numbers, it's going to be pretty hard to draw them. So instead of like, or even like the name of it, because let's be honest, I don't know the name sometimes. So like say for instance, if a polygon has 20 sides, what am I going to call it? Well, I'm just going to go ahead and be super lazy. I'm going to call it a 20gon. Alright, I'm not going to try to look up what the name is or anything like that, or even try to pronounce it. Okay, so let's just go ahead and move on.